In this problem, we again have two cars, but now they're headed in the same direction. So they're both going in the same direction, and we know the momentum, we know the mass and the velocity of the car that's behind. We know the mass and the velocity of the car that's ahead. And eventually the trailing car, the one that's behind, runs into the lead car and bumps into it. Afterwards, the trailing car has a new velocity. The question is, what's the velocity of the lead car? So let's start looking at momentum. The momentum beforehand, m1 v1, and this time it's going to be plus because they're headed in the same direction. v2 equals. Afterwards, m1 v1 prime plus m2 v2 prime. Now we know everything in this equation except v2 prime. So let's begin solving for v2 prime. m2 v2 prime equals, I'm going to copy this, but that is now minus, all right? So m1 v1 m2 v2 minus m1 v1 prime equals m2 v2 prime. And now we just have to divide both sides by m2. Divided by m2. And this is our equation for the velocity of car 2 after the collision. Now, what would you intuitively expect? We got a car that's going faster that bumps into a car that's going slower. After the fact, the car that was going faster is going even slower. What do you think is happening to the other car? Well, let's find out. V2, V1, M2, V2, and then V1 prime. We know that. All right, let's stick in the numbers. We've got 1481 kilograms at 15.9 meters per second and 1229 kilograms at 13.9 meters per second. And then afterwards, car 1 is going 10.4 meters. And let's calculate V2 prime. Parentheses, M1 times V1 plus M2 times V2. You see I've got a typo there. Minus, right, M1 times V1 prime divided by M2. Correct this real quick. So we now know that the second car, or the lead car, is now going 20.53 meters per second. 20.53 meters per second. And that's the end of this problem.